Hello and welcome to this lesson about orders of operations. The learning target of this video is properly using order of operations. And in this one we'll be looking at examples that have negatives or could have negatives as well as larger exponents. So first of all, let's talk about what it is. So there's two things we have to know with order of operations. The first is this acronym, PEMDAS. And the way this works is that each one of these letters stands for a different operation. So the P stands for parentheses, the E stands for exponents, the M is multiplication, the D is division, the A is addition, and the S is subtraction. And these each work in sort of different tiers. So first, you'll start off, it's order operations, so it's all about how you approach a problem. But you start off with parentheses. Then you work with the exponents. And where it gets tricky is that multiplication and division are grouped together. And the way you approach them is you work left to right. So whatever you encounter first is what you'll do first. So if you see a division sign before multiplication, you'll do the division. And then the same thing happens with addition and subtraction. You work left to right. So with that being said, we could actually make PEMDAS into a whole new acronym, PEMA. And the way that works is you can get rid of division and subtraction by using their inverse operations. So just think about this for a second. Subtracting 2 is the exact same as adding -2. Multiplying by, or sorry, actually not multiplying, dividing by 2 is the same as timesing by 1/2. And so by doing that, we eliminate the division and the subtraction, and really we're looking at PEMA. Or you could also just remember to do it from left to right within those groups of orders. So multiplication, division, and addition and subtraction. The second thing I want you to kind of take away from order of operations and why it matters and what's the big deal behind it is that it is all about being consistent. How can we develop, or what is the process for arriving at the correct answer each and every time? So order of operations is about consistency. So that way wherever we're doing math, at whatever time period we're doing math, we're getting the exact same answer. So that's the other idea I want to get across. It's all about consistency. So now let's take a look at some examples. We'll start off with something just like this. 5 times 4 minus 6 divided by 2. Now, for those of you who are newer to order of operations or struggle with math in general, I'd recommend that you always write PEMDAS by these problems. You can just write it once on the sheet of paper. You can write out each problem, whatever works for you. And just kind of work your way through it. So P, there's no parentheses. Don't have to worry about that. Exponents, don't have to worry about that either. Multiplication, division, remember we do these together. We do the addition, subtraction together. We have to worry about multiplication and division. We have 5 times 4 and 6 divided by 2. 5 times 4 is 20. And then what we can do is we can also do 6 divided by 2 at the same time. Minus 6 divided by 2, and that would be 3. Now, the mistake a lot of people are going to make is they're going to be super duper tempted to not write minus 3 and just to write this, and then to see 20 minus 6 and do that subtraction. Avoid that mistake. So, got to kind of put blinders on there and realize that you have to do this division first. Once we do that division, we can now do the subtraction, 20 minus 3 for 17. And now, let's change things up just a little bit. We'll use the same numbers. And I love doing this with order of operations just to kind of highlight something. And so now, let's say we're going 4 times 6 minus 2. All right, so as you can see, it's the same numbers. But according to order of operations, we have to do multiplication first. And so this is what I like to refer to as a test trick. This is something that textbook companies and teachers will do to make sure you're paying attention. Are you doing the multiplication first? A lot of students will be tempted to go 5 plus 4, which is 9, and then times it by 6. But you do not do that. You have to do the multiplication first. So we'll have 5 plus 24 minus 2. Now we need to work left to right. So we'll go 5 plus 24, which is 29, minus 2, which is 27. So that's some great basic examples. Let's now kick it up a notch. Let's consider this problem. The quantity of 18 divided by -9, all raised to the third power, minus 5 times 2 plus 8. Okay, so now we have to do our parentheses first. We have to address what's going on in here, which is 18 divided by -9. That's going to get us -2. And we're going to put this in parentheses. Now we're going to do a quick aside here. Think about what -2 to the third power is. That means -2 times -2 times -2. We multiply these two together, we'll get +4, and then multiply by -2 again, leaves us with -8. So we'll eventually write -8 in for that. But next, we'll finish out writing all this, so -2 cubed minus 5 times 2 plus 8. And so now we'll address the exponent, -8 minus 5 times 2 plus 8. Oopsies, let me erase that. Okay. And now we have to do our multiplication. And our multiplication is 5 times 2, so we'll have -8 minus 10 plus 8. Now here's where we have to keep in mind that idea of PIMA. We're going to do addition and subtraction as we see it. And so I'm seeing 10 or -8 minus 10. So that's actually going to become -18. Do that first and then add 8. The mistake a lot of people are going to do is do these two first, which you should not do, and that's going to throw everything off. Now I have -18 plus 8, and that gives us -10, and there we go. That's our final answer. So now let's get to a question that I'm sure some of you are wondering. How difficult will this get? All right, it just takes a lot of practice to get used to how to do order of operations, but after a while you kind of figure it out. But how can a teacher make it super duper tricky? So let me show you a problem. The way we can make these complicated is by making a fraction and just having you keep track of everything. Now, one thing that I want to get across before I get started is that a big fraction, which is what we're going to call this in loose terms, is equal to 2 sets of parentheses being divided. So our numerator is in parentheses, our denominator is in parentheses, and we're going to focus on the numerator and denominators separately until we dwindle them down to a number. Then we will combine them. So let's see here. First, let's start off with addressing the numerator, taking care of these. 7 plus -2, that's going to give me 5 squared. Minus, and then here I'm going to do 6 divided by -6 is 1. Over, and then I'll take care of my denominator, do my division first, 5 plus 3. And so one of the main mistakes I've seen students do with order of operations is just not taking your time, trying to do too much at once. Slow things down. So 5 squared is 25 minus 1 over 5 plus 3 is 8. Because when students rush, and I do this too, when I rush, I see things and I kind of assume them to be one way when in reality they're not. And if I just taken the time, I avoid embarrassing myself and making some mistakes. And so 25 minus 1 is 24 over 8. That gives me 3. And so again, this is how I'm going to make this super complicated. This is how textbook companies or test companies are going to make things difficult, is by putting it in parentheses and just really having you focus and pay attention to all the details. But after that, it's just all about the process. So keep in mind a couple of things. Never hurts to write down PEMDAS when starting the problems. And that when you're dealing with multiplication and division, this is a group, and addition and subtraction is a group, and you work left to right. And then besides that, just take your time. So hopefully this answered some questions and taught you how to do or how to apply order of operations. Let me know if you have any questions.